Alright, so data encapsulation. So now we basically want to look at all what we've discussed so far in the course of a couple of few paragraphs or topics in this chapter 1. Everything that has had to do with how the data is processed at the different layers of the OSI model. Remember, we mentioned that data encapsulation is basically that process whereby as the data is being handed down or is passing down from the different layers of the OSI model, the different upper layers of the OSI model, they are encased with control information, with added information that will help the host to be able to send the data to the correct receiver, and then the receiver, on receiving the message, will be able to analyze, process, and then retrieve the original message that were sent to it. So usually the concept I usually love to apply when it comes to data encapsulation, I usually want to imagine or thinking about putting a letter in an envelope, so that as it is going through, as that letter, you have think of data encapsulation as you writing a letter that you want to send to a friend who is abroad. Now, as the letter is going from one post office to the other, it is being wrapped in different envelopes. Okay, as it is, if you would, let's say you want to send a letter to somebody in the United States. After you finished writing your letter, the first post office you take your letter to is the post office at Wuse. And by the time you get to the post office at Wuse, they process your letter, they read your letter, and then put it inside an envelope and they stamp it, and you write a particular address. Then the post office at Wuse would now, let's say it sends it to their National Post Office Service in Lagos. Let's say Lagos headquarters of Nigerian Post Office. By the time your letter gets there, before it now moves internationally, your letter is now put inside another envelope, another bigger envelope, and stamped, and the bigger envelope is stamped, and then it's now ready to be sent out of the country. And let's say when your letter now gets to the country, gets out of the country and gets to the receiver's country, at their own post office, they now put it inside another bigger envelope, put another stamp. Just think of data encapsulation in that way, and it'll make it easier for you to understand what is happening as the data is moving from the different layers of the OSI model. So let's start looking at it from what the paragraph has to explain. It says when a host is transmitting data across the network to another device, that data goes through encapsulation. Okay, so that encapsulation is what helps the host to be able to transmit that data from itself to a receiving device. And that encapsulation is basically protocol informations that are used to wrap the main data at each layer. So each layer of the OSI model, starting from the transport layer, they have their own protocol information, control protocol information that they will wrap the main data in, and that will help the information at a particular layer to be able to communicate with the adjacent layer on the receiving device. So if I wrap at the transport layer, when I wrap the information on a particular, or I encapsulate the information with a particular protocol, at that transport layer on the host, by the time the data gets to the receiver and the receiver receives it, it is the encapsulation that took place at the transport layer of the host that will help the transport layer of the receiver to know what to do with that data. That's what it means, that each layer communicates only with its peer layer on the receiving device. Now, to communicate and exchange information, each layer uses PDU units, protocol data units. Okay, these are the control informations that are encapsulated to the main data as it is going from layer to layer. So these are protocol data units, or what you might call the envelopes in my illustration. They are basically what hold the control information to the data. Okay, the main data itself, the main letter itself that you're about to send is the data, but the control information that are now encapsulated at each of the layers of the OSI, those are the protocol data units. So these protocol data units, they are like the envelopes. Okay, and with the normal post office, on the envelopes you now have either your stamp or your address. That stamp or the address on the envelope is what will guide the person who is sending that message to know where to send the message. So these protocol data units are like the envelopes, and they hold the control informations that are attached to the data at each layer of the OSI model. So they are usually attached either at the header in front of the data field or the trailer at the end of the data field. Now each PDU attaches to the data by encapsulating it at each layer of the OSI model, and each has a specific name depending on the information provided in each header. The PDU information is read-only by the peer layer on the receiving device. So that's what I meant. So the PDU information that is encapsulated at the network layer will be used by the receiver at the network layer. So if at the host, from the host side, the message the sender is about to send, he includes the PDU information at the network layer. The only person that can make use of that information at the network layer is the receiver. Once the receiver receives it and the message gets to the transport layer, the network layer, the receiver will be able to make use of the information. What that means is, if at the national level, at the Lagos level, the new envelope that was used to package both my letter and the first envelope at Wuse, by the time the letter gets to our Lagos headquarters before it moves out of Nigeria into another country and it's encapsulated in a bigger letter, is only when it gets to another foreign country the headquarter envelope that was used to encase will be made use of at the national level of another country. The state level of the envelope will be made use by the state level of the receiving country. I hope that should make it clearer for you to understand what it means that the PDE information is read only by the peer layer, the same layer on the receiving device, because each of the devices, they have the same OSI model. Me that is sending the data, I have the transport layer, the network layer, the data link layer, and the physical layer. The receiver too has all these layers too. So if I'm encapsulating data at the network layer, it is the receiver at the network layer that will make use of that encapsulation that I've done at the network layer on my own. If I do the same encapsulation at the transport layer, it is the receiver that will make use of that encapsulation at the transport layer in his own transport layer as well. So that's how it flows. Now each PDA attaches the data by encapsulating it at each layer of the NSI model, and each has a specific name depending on the information provided in each header. This PDU information is read-only. Okay, after it's read, it is stripped off and the data is then handed to the next layer up. So after you have received the letter at the same level, at the national level, they will remove the inner envelope and then throw away the national level envelope and then pass on what is in. They will the receiver, let's say the receiver on the receiving country, by the time he receives our national envelope, he will open the national envelope section, remove the state level envelope inside, and then throw away the national envelope. By the time the state level envelope is now sent to the local government level envelope in the receiving country, the local government envelope will now open the state level envelope and bring out the local government envelope inside, and then throw away the state level envelope. That is what it means when it says that after it is read, it is stripped off and the data is then handed to the next layer up. Now the figure here now shows the PDUs and how they attach control information to each layer as it is going. So this figure is now looking at it from the host or the sender's perspective. What is happening as the sender is processing the data to send to a receiver. Now, we have 7 layers on the OSI model. So the application layer starts its work to present. These 3 layers do not do any form of encapsulation. Application, presentation, and session. These guys don't do any form of encapsulation. Encapsulation starts at the transport layer. So these guys are the ones that will prepare the main data itself that is about to be sent. That's the upper layer data. They are the guys who prepare the main data itself that you need to send to your receiving host. Everything is processed at the application, presentation, and session layer. They make the data itself available. So, so the data stream is then handed down to the transport layer. So after they have finished with preparing the data or generating the data, they now send the data to the transport layer for the encapsulation processes to commence. Now let's look at how the encapsulation layer, the encapsulation starts. Okay, so the transport layer here sets up a virtual circuit. Remember we mentioned something about this when we were discussing about three-way handshake and the rest of them. It sets up a virtual circuit to the receiving device through synchronization and acknowledgement and all of that. Try and remember these things because they are related. So once it finishes and accomplishes that synchronization and acknowledgement, data stream starts getting broken down into smaller pieces. So at this transport layer, all this big chunk of data will now be broken down into smaller pieces of data that will now be sent segment by segment. Now, after the data stream, the big data is broken down into smaller pieces of data. The transport layer now adds its own PDU. Okay, it creates its own PDU and attaches it to the header of the data field. So this is what you're seeing at the transport layer. So after the main data itself has been provided, so after it has broken this down into smaller level, the TCP layer will now add its own PDU control information of its first envelope to the main data itself to get it ready for transmission down below to the next layer below. So at that point in time, this main letter has now been encased in the first envelope or encapsulated in the first envelope, and at this segment, at this stage in this layer, this data has now been converted into a segment. By the time this TCP header field is attached to this main data, the information now is converted into a segment at the transport layer. So each segment is now sequenced. Remember when we discussed sequencing as a way of controlling data loss in the transport layer. That's connection and reliable and unreliable delivery, all those things we discussed at the TCP. Now each segment is sequenced so that data stream can be put back together when the receiver receives it. Okay, at the receiving end, the receiver will be able to receive it exactly the way it was at the transmitting end. So here we have a segment at the transport layer. So after this has been done, this segmentation has been done, it is now passed down to the network layer. Now each segment is then handed down to the network layer for network addressing and routing through the network. So it is at the network layer that now logical IP address informations are used to provide to encapsulate on the segments to be able to provide routing and network addressing and the rest of them. So logical addressing is used to get each segment to the correct network. The network layer protocol now adds its own control header, that's its own PDU, to the segment that has been handed down from the transport layer. So as the message now came from the transport layer, the network layer will now add its own. So these two guys are what is making up the data here. these two guys represent the data here. Now the network layer will now add its own PDU information that has to do with networking, routing, and the rest of them on the IP header field. So once it does that, you now have this segment will be converted into a packet or a datagram. So at this layer 3 here, the information now is converted into a datagram or a packet. So once that is done, remember it says that the transport layers and the network layers, they work together to rebuild the data stream on the receiving host. So remember that this was the main data. At this stage, this guy breaks the main data into smaller datas in order to be able to send them. Then it segments them, as adds its own header to each of them, then sends each of those smaller segments to the network layer. The network layer will add its own PDU information, converting it into a packet or a segment, and then getting it ready for sending, so that when these two guys at the receiving end receive the information, they will be able to use the informations at the header, at the PDU informations, to rebuild the data stream and obtain the data exactly the way it was transmitted by the host. But take note that it's not the network layer that handles having to place their PDUs on the local segments. That is where the data link layer comes in, does its own work. The data link layer will now is the guy who takes the packets from the network layer and then places them on the network medium, that is on the different interfaces on either the router or the switch, in order for it to move out either to a network or to the host itself. So at the data link layer, an encapsulation is also done. PDUs are also added to the packets that are received. So as their own PDUs are added to the packets that are received, this will now be converted into a frame. You can see that there are two levels of encapsulation that happens at the data link layer. Remember when we discussed the two sub layers of the data link layer, that we have the LLC and the MAC. So while this one takes care of the addressing, this one takes care of how the protocols will be able to handle this information when they receive it. So the frame's header carries the hardware addresses of the source and destination hosts. If the destination device is on a remote network, that is, if the receiver is destined for a remote network, the data link will now place the frame or send it to a router to be routed to a network. So once it gets to destination network, the receiving frame is now used to get the packets to the destination hosts. So the data link layer usually helps to reroute and then forward the packet or the message to the intending receiver or recipient of the message. So to put the frame on a network, of course, the frame, it must first be converted into a digital signal. Okay, since the frame at the data link layer, the frame is just a logical group of ones and zeros. The physical layer is now responsible to encode this series of ones and zeros into a digital signal. It's a logical group of ones and zeros. But the physical layer is now going to convert these logical group of ones and zeros actually into digital signals, okay, that have voltage levels that the devices will now send and receive to each other on the same local network. So the receiving devices will synchronize on the digital signal and extract the code. Remember when we discussed the different parameters of the Ethernet frame network, and we discussed the FCS frame check sequence field. These are used to synchronize series of ones and zeros that are used to provide clocking between the host and the receiver, so that they will be able to receive the frames and then build the frames, run a CRC, cyclic redundancy check, and then confirm that what is being received is the same as what was being sent. These are all the responsibilities of the physical layer, so that if there is a match, the packet will now be pulled and the process of de-encapsulation will now commence. De-encapsulation is the reverse of what encapsulation is. It's the process of taking out the, because in the encapsulation process at this stage, what they're doing is each data is put inside an envelope, sealed, sent to the next layer. The next layer will put inside its own envelope, seal it, send it to the next layer. The next layer will put inside its own envelope, seal it, put it down. So you have series of envelopes put inside other bigger envelopes. So this is encapsulation process. So the de-encapsulation process is at the receiving host, where each envelope will be removed, discarded, removed by the next layer, discarded, removed by the next layer, discarded, and the rest of that. So the packet is handed to the network layer. So at the receiving end, we'll look at it much later. At the receiving end, the encapsulation starts. How does it start? First, when the receiver receives the digital signals, it will extract or decode the ones and zeros from the digital signal, and then the data link will build the frames, run a CRC check, and then confirm that the frames FCS field is the same as what was being sent. So if there is a match, the data link layer will pull out the packet from the frame and then throw away the frame that was used to encapsulate it at the host. Then the packet will be sent to the network layer. The network layer checks the address, it pulls out the address information, checks the address. If that's the network address, if the network address matches, then it pulls out the segment that was inside it and then throws away the packet, what is left of the packet envelope or information or encapsulation data that was on. It now sends the segment to the transport layer of the receiving host. The transport layer will now rebuild the data stream and acknowledge the transmitting host that it has received the message, and then it will now discard the segments header and then send the data stream, the main data stream, now to the upper layer, which is the session, the presentation, and the application layer for activity. So this has been broken down here into its composite stages or levels in this list. So it says that the transmitting device, this is what happens in the encapsulation process. The user information is converted to data for transmission on the network. Okay, now that is from that's the first three layers: the application, presentation, and session. They provide information that is to be sent on the network. Now the data is now sent to the transport layer. At the transport layer, that data is converted into segments. Okay, converted into segments, and a reliable connection is set up between the transmitting and receiving hosts. So at this point, while the data is sent to the transport layer, remember it will be segmented, and as it's segmented, the transport layer will initiate a connection, a virtual circuit with the receiver, for the receiver to be able to start preparing to clock. It sets up a virtual circuit connection with the receiver, a reliable one. Either that's if it is reliable, if it is TCP, it's going to be a reliable connection. It is going to set up the virtual circuit. But if it is not TCP, if it's UDP, which is not reliable, it doesn't need to set this up. So it finishes preparing the data, converting it into a segment, provides a sequencing and everything on it. It's ready. It now sends it to the network layer. At the network layer, those segments are now converted into packets or datagrams. They are converted into packets or datagrams. And that's packet is for TCP, datagram is for UDP. Packet is for reliable, datagram is for non-reliable. So at that point in time, they are given logical addresses. That is, the network layer does its own encapsulation, gives it the logical addresses, places it on the header so that the packets will now be ready to be routed through the network. So the information now in the packet form is sent to the data link layer. The packets or the datagrams now at the data link layer will be converted into frames for transmission to the local network. So the data link layer will do its own encapsulation, add the hardware Ethernet addresses, that's the MAC address, and use it to uniquely identify hosts on the same local network segment. So once the data link layer is done with its own, it now sends it to the physical layer. Physical layer will now convert the logical ones and zeros, which are the frames, into digital signals that have voltage levels that will be sent to the receiver. So the digital encoding and clocking scheme is used, just like we mentioned before. So this is basically what it looks like. This was the main data when it entered the transport layer. When it entered the transport layer, it was converted into segments, and then the rest of this represents the envelope that is carrying the data. So that the segment layer, you have this information such as the source port, the destination port, and some other relevant information. These are what is going to be. So this is where you specify whether the information came from a web address, which is sometimes you use the port to identify, which will be HTTP, which is port 80. You just get to know which ports originated the message and which it's destined for. That's what the source port information provides. Then at the packet level, you have, that's this segment now gets here. These are the informations added at the packet level: the source IP, destination IP, the IP protocol that is being used, along with some other things. It gets to the data link layer. These are the packets. This is the packets at the data link layer. It adds a frame check sequence information. It adds an ether field, the type of protocol, MAC address, and destination source MAC address and destination MAC address. So at that point in time, this thing is ready, and it's converted into bits at the physical layer into 1010 signals, digital signals to be sent out. So remember that the data stream is handed down from the upper layer to the transport layer. As technicians, we really don't care who this data stream comes from, because that's really a programmer's problem. So programmers are the ones who do this. Our job is to rebuild the data stream reliably and hand it to the upper layers on the receiving device. So that is what administrators do, to be able to ensure the smooth routing or movement of the data, from reliable delivery of data from sender to receiver. Before we go further in the discussion of figure 1.0, let's discuss port numbers and make sure we understand them. The transport layer uses port numbers to define both the virtual circuit and the upper layer process, as you can see from this particular figure. So now, looking at this, you will now identify here that these are port numbers. It's basically used to identify which protocol started this and which protocol it's requesting for. What I mean there is, look at source host A. He is the one that defines the virtual circuit. This guy's port address is 1028, and he's specifying that the message he's sending is intended for a port 23, an application that uses port 23 on the receiver. So the upper layer process or application. So this is the upper layer process or application on the receiver. Okay, and in some cases, the source port here would represent the individual hosts, whereas the destination port here, because when you're communicating with somebody, basically you're asking the person for a particular information, and the information that you're asking for will come from one port or the other. I may not be able to describe or explain this pretty clearly, but as we go down in the course, we'll be able to understand what port addresses actually stand for and how they help in the whole routing process to send data from a host to a receiver. So the transport layer takes the data stream, makes a segment out of it, and establishes a reliable session by creating a virtual circuit. Then it will sequence each and every one of those segments and then uses acknowledgement and flow control, as if you're using TCPO. The virtual circuit is defined by the source port number. That's the host port number. Remember, the host just makes these up starting at port numbers 1024. Already 0 through 1023 are reserved port numbers. You cannot assign that to an individual host. But from 1024 up, you can see this one is 1028. It represents a host. They are just port numbers that represent a particular host. Don't worry, we'll look more at this by the time we go higher in the course.